December 7, 1943. The bitter cold of Detroit sliced through the air as morning fog rolled across the Rouge River, carrying the metallic tang of machinery and oil. Inside the sprawling Ford Motor Company plant, the relentless rhythm of thousands of workers echoed off steel and concrete walls. Hammers clanged, machines whirred, and the smell of hot metal mingled with the faint odor of coal smoke from the boilers. This was no ordinary factory. It was the beating heart of American wartime production, where innovation collided with sheer human determination. The world was at war, and the skies over Europe were darkened by the shadow of the Luftwaffe. Yet here, in this industrial cathedral, engineers, mechanics, and assembly workers were quietly rewriting what seemed impossible. Across the Atlantic, German intelligence operatives monitored every scrap of news about Allied production. They had anticipated efficiency, but nothing could have prepared them for what they were about to witness. Ford was producing a bomber, a massive, complex B-24 Liberator. Every 63 minutes, yes, a single aircraft composed of 1.5 million individual parts, assembled faster than the enemy's spies could comprehend. It was a machine of astounding scale and intricacy. The B-24 Liberator, with its long wingspan, 4 powerful engines, and bomb bay capable of carrying thousands of pounds of explosives, demanded precision at every turn. Any misalignment, any flaw, could compromise a mission hundreds of miles over enemy territory. Yet here in Detroit, the assembly line ran like clockwork, a symphony of human skill and mechanical prowess. The story of this transformation begins not with wartime necessity but with Henry Ford himself. Known worldwide for revolutionizing the automobile with the Model T, Ford had become a master of efficiency. But a bomber was not a car. It was far more complex, and the stakes were infinitely higher. From the outset, Ford and his engineers faced an unprecedented challenge: how to turn the chaos of raw metal rivets, engines, and instruments into an aircraft that could dominate the skies. The answer lay in scale, standardization, and sheer industrial audacity. Ford had perfected the moving assembly line, but wartime production demanded more than speed. Every worker was trained meticulously in a specific task. Thousands of men and women, often working in shifts that lasted long into the night, repeated the same actions with unwavering precision. Rivets were placed by hand in some sections, yet in others, machinery did the work, timed to the exact heartbeat of the line. The roar of drills, presses, and conveyors became a rhythm that carried the aircraft from bare framework to completed bomber, ready for deployment. Meanwhile, German intelligence reports trickled back to Berlin with alarming clarity. Spies, stationed across neutral countries, struggled to make sense of the data. How could one factory produce hundreds of bombers each month when Europe's finest engineers toiled endlessly with nowhere near the same output? Reports describe the vast expanse of the plant, the organized chaos of parts arriving from suppliers across the United States, and the precision of workers whose movements were choreographed down to the second. It was industrial wizardry, and it terrified the German command. Every bomber that rolled off the line represented another night raid over German cities, another payload dropped on strategic targets, and a growing sense of inevitability in the outcome of the war. Inside the plant, the human story was equally remarkable. Women, filling roles traditionally held by men who were now at the front, moved with both determination and a sense of purpose that reverberated through every bay. They had learned to operate heavy machinery, rivet fuselage sections, and calibrate instruments with astonishing speed. Young men, many of them just barely of age, handled complex electrical systems under the watchful eye of seasoned engineers. The air was thick with sweat, oil, and urgency, yet there was also a sense of quiet pride. These workers understood the gravity of their labor. Every precise motion could save lives thousands of miles away. And then there were the engineers. Their task was to maintain the delicate balance between speed and quality. One miscalculation could ground a fleet, or worse, result in a disaster mid-mission. In response, Ford implemented rigorous inspections, double-checking every critical system before a bomber left the line. Engineers moved between stations, their eyes scanning instruments, gauges, and fasteners. When necessary, they would halt production for minutes, even hours, to ensure nothing was left to chance. This relentless attention to detail created a culture of both urgency and meticulousness, a combination that would leave German spies utterly astounded. The scale of the operation was staggering. Raw materials poured in from across the country, aluminum from the Midwest, engines from Detroit, bone factories, instruments calibrated in Philadelphia, and bomb racks manufactured in Ohio. Each part traveled across miles of conveyor belts, loaded onto trucks, and then onto the assembly line, synchronized perfectly. Observers from Allied military command often described as watching a giant mechanical organism breathe and grow, a living testament to what humanity could achieve under pressure. Outside the factory walls, the world remained unaware of the full scale of this production marvel. Yet German agents analyzing captured photographs, intercepted communications, and eyewitness accounts began to sense that something extraordinary was underway. One report noted, almost in disbelief, that the assembly line moves with the precision of clockwork, yet produces machines of unimaginable complexity in record time. How could this be possible, they wondered. How could an aircraft with 1.5 million parts be built faster than the Germans could destroy their targets? Questions like these haunted intelligence offices across Berlin. Reports described workers bending over fuselage frames, hands moving in perfect rhythm, and machinery synchronized to the heartbeat of the operation. One spy, in a coded telegram, wrote, "Ford's plant is beyond comprehension. Every hour, another bomber. The enemy is unstoppable if this continues." Yet behind the industrial marvel lay countless human stories. A young riveter named Mary Allen, whose father had died in France, placed each rivet with the memory of his sacrifice in her heart. Engineers risked burns and injury daily to ensure each wing and fuselage section was flawless. Forklift operators, mechanics, and clerks all understood the stakes. They were building not just aircraft, but the very backbone of the Allied air campaign. The air smelled of oil, hot metal, and sweat, but also determination and hope. Even as German spies attempted to analyze and report, the factory kept moving. Each hour marked another bomber joining the fight, a tangible proof that the United States industrial machine had become as formidable a weapon as any bomber or gun. And within this hum of machinery and human endeavor, a silent tension persisted. How long before Germany realized the true scale of what they faced? How many more bombers would Detroit's assembly lines unleash before the Luftwaffe could respond? In this crucible of innovation and urgency, the impossible became reality. Ford's factory was no longer just a production plant. It was a symbol of American resolve, a testament to human ingenuity and an unrelenting force that left even the most seasoned German intelligence officers stunned, scrambling to understand a power they could neither slow nor stop. By early January 1944, the roar of the Ford Rouge plant had become relentless. Engines thundered, conveyor belts hummed like a giant heartbeat, and the smell of heated metal, oil, and industrial polish hung thick in the winter air. Thousands of workers, women and men alike, moved in near-perfect coordination there, eyes trained on the assembly line, their hands precise, almost robotic. Each B-24 Liberator required 1.5 million parts, yet somehow, every hour, one emerged fully assembled, tested, and ready for deployment. The process was a feat of logistical genius. Raw aluminum sheets arrived by rail, arriving in massive stacks. Workers cut, bent, and riveted them into fuselage panels, wings, and tail section. Engines, supplied by Detroit's own massive industrial network, were fitted with exacting precision. Wiring looms stretched through the fuselage, tiny instruments carefully calibrated to ensure operational reliability thousands of feet above enemy territory. Each step was documented, inspected, and, if necessary, repeated. No error could be tolerated. What fascinated German agents most, and caused them the most alarm, was the sheer speed, without sacrificing quality. Intercepted spy reports described disbelief. Every 63 minutes, another bomber leaves the line, fully armed and tested. This is beyond anything we anticipated. The enemy's capacity is staggering. They noted the seamless coordination between engineering, assembly, and logistics. Components from different states, produced by countless factories, arrived on time, every time, fed into a system that seemed impossibly efficient. Ford's assembly line wasn't merely a factory. It was a carefully choreographed ballet of human skill and mechanical precision. Teams of workers specialized in their tasks. One group would install landing gear. Another riveted fuselage sections together. Women operated complex machinery once reserved for men, pressing metal with exacting force, calibrating rivets to withstand turbulence and combat stress. Men with mechanical experience fine-tuned engines, checked hydraulics, and tested bomb bay mechanisms. Every station had a purpose, and every worker understood the stakes. Meanwhile, German spies struggled to comprehend the operation. Photographs smuggled out of neutral ports showed the sheer size of the plant, miles of conveyor belt, massive cranes hoisting fuselage sections, and hundreds of workers moving in perfect synchrony. Reports repeatedly emphasized the shock of one observation: the assembly line does not stop. Not for lunch, not for repairs. The rhythm is unbroken. The output is unstoppable. The human stories behind these machines were equally compelling. Women like Betty Riddle, a riveter from Ohio, would work 12-hour shifts, hands blistered and blackened with grime, yet driven by purpose. Every rivet I placed could help someone survive a mission, she recalled years later. Engineers like Carl Johnson slept only a few hours each night, yet meticulously inspected each system, aware that a single flaw could cost lives over Europe. Forklift operators maneuvered massive wings and fuselage sections with millimeter precision, and clerks tracked the movement of every part, ensuring no delays. The factory became an ecosystem of skill, discipline, and sheer determination. Yet even amidst the mechanical symphony, suspense lingered. Could the line hold up under increasing pressure? Could the rapid pace introduce mistakes that would ground the fleet? Each bomber leaving the plant carried with it not just 1.5 million parts, but the weight of human ingenuity, courage, and responsibility. The technical details alone were staggering. The B-24's high aspect ratio wings allowed for extended range and heavy payload, yet they required exact assembly to avoid catastrophic failure in flight. The 4 Pratt & Whitney engines had to be perfectly synchronized, their cooling systems and carburetors meticulously calibrated. Bomb bays, reinforced with steel and outfitted with mechanical release mechanisms, were tested repeatedly. Every control surface, every cable, every gauge underwent rigorous inspection. And yet, despite this complexity, production continued at an unprecedented rate. German intelligence was left grasping for explanation. Reports described spies analyzing photos, tracking shipments, and even attempting to calculate assembly speed. Their conclusions were tinged with disbelief and fear. This is not just industrial capability, it is a weapon in itself. The enemy can replace losses faster than we can strike. How is this even possible? Some officers doubted the intelligence at first, convinced the numbers must be exaggerated. But further observation confirmed it. Ford's plant had achieved what the Luftwaffe and Kriegsmarine could scarcely imagine: a perfect balance of speed, precision, and scale. What made the factory truly remarkable was the integration of innovation and standardization. Prefabrication allowed wings, fuselage sections, and engine mount to be constructed separately, then joined seamlessly on the line. Jigs, templates, and guides ensured parts aligned perfectly, reducing errors and speeding assembly. The moving assembly line, borrowed from automotive production, allowed each worker to focus on a specific task, repeating it with consistent accuracy. The cumulative effect was astonishing. 1.5 million parts coalesced into a single bomber, ready for the skies, in just over an hour. Meanwhile, the human drama continued. Workers endured exhaustion, frostbite from poorly heated bays, and the constant pressure of wartime urgency. Yet morale remained high, fueled by a sense of purpose. Stories circulated of workers pausing briefly to watch the aircraft taxi off the line, imagining the missions it would fly, the lives it might protect, or the enemy it would confront. Every bomber represented not only technical mastery but a collective human effort on a scale never before seen in history. By mid-1944, the impact of this production marvel was clear. The Allies now had an air arsenal capable of sustained bombing campaigns. Force multiplier that German intelligence could neither ignore nor counter. Quickly, intercepted reports described panic in Berlin, the realization that no single raid could halt production, that losses could be replaced in hours, not weeks. It was a psychological as well as tactical shock. The very efficiency of Ford's plant became a weapon in itself, undermining enemy morale and demonstrating the power of industrial ingenuity. Even the minutiae of the operation held fascination. Factory managers developed color-coded parts lists, intricate scheduling charts, and cross-checking systems to prevent delays. Engines were tested on dynamometers. Before installation, instruments were calibrated with meticulous care. Bomb racks were pre-assembled and installed with precision timing. The entire operation resembled a living organism, each part essential, each worker a vital organ. And yet, despite this complexity, the line never stopped. Each hour another bomber emerged, another arrow in the Allied quiver. And so, as December turned to January, German agents watched in stunned silence. Every report reinforced the same terrifying truth: the Ford Rouge plant was more than a factory. It was a symbol of industrial determination, human resilience, and the sheer audacity of a nation at war. For every bomber it produced, the enemy's hope dwindled. For every rivet placed, every engine tested, the balance of power shifted ever further in the Allies' favor. By spring 1944, the scale of Ford's achievement had become undeniable. The roar of the Rouge plant was constant, a relentless pulse echoing across Detroit. Engines thundered, gears spun, and hundreds of workers moved in near-perfect choreography. Rivets flying, wings hoisted, and fuselages joined with astonishing precision. Outside the plant, the world seemed oblivious. but across the Atlantic. German intelligence officers were in a state of disbelief and growing panic. They had sent spies, analyzed photographs, intercepted communications, and yet the numbers refused to lie. Every 63 minutes, a fully assembled B-24 Liberator emerged from the assembly line, each composed of 1.5 million parts. The implications were staggering. German agents realized that their previous calculations of Allied production had been hopelessly outdated. The bomber output alone meant that no single air raid could cripple American capabilities. Losses were replaced faster than they could be inflicted. It was more than a logistical feat, it was a psychological weapon. Reports from Berlin were grim. The enemy's capacity is inexhaustible. Every hour, another bomber. Their skies are endless. Inside the plant, tension and determination intertwined. Workers pushed themselves to exhaustion, driven by both patriotism and a deep understanding of the stakes. Riveters like Mary Allen and Betty Riddle moved with fluid precision, the rhythm of their hammering almost hypnotic. Engineers double-checked instruments, recalibrated engines, and ran repeated tests to ensure each aircraft could endure the rigors of war. There was no room for error. Every plane represented not just military strategy but human lives, both those who would fly it and those who would depend on its success. The B-24 itself was a marvel of engineering. Its long, slender wings provided unprecedented range. Its 4 engines delivered remarkable power, and its bomb bays carried payloads capable of reshaping battlefields. Yet, the most remarkable feat was not just in the aircraft's design, but in the human and mechanical coordination required to bring it to life so rapidly. It was as if the factory had become a living organism, each worker and machine a vital organ. In a body that could produce lethal instruments of war, with the precision of a Swiss watch, German spies, frustrated and terrified, attempted to report these developments. But the implications were overwhelming. How could a nation build so efficiently, so rapidly, with so many moving parts? Every new intelligence report only reinforced a terrifying truth. Allied industrial capacity had become a force multiplier beyond anything imagined. The factory was not just producing planes, it was shaping the course of the war itself. Meanwhile, the human story of the workers deepened the emotional impact. Men and women, often young and untested, labored under intense pressure. Their hands black with oil, faces streaked with sweat, yet eyes resolute. They endured fatigue, harsh winter drafts in unheated bays, and the constant awareness that mistakes could cost lives. Yet they persevered. Each completed bomber was a testament to collective effort, ingenuity, and courage. Some paused briefly to watch the planes taxi off the line, imagining the missions, the bar, flying over enemy territory, and the protection they offered to their comrades abroad. Even minor innovations had strategic consequences. Prefabrication and modular construction meant that wings, fuselage sections, and engine components could be assembled independently before being integrated seamlessly on the line. The moving assembly line allowed specialists to perfect their task without interruption. Rigorous inspections ensured that no defect went unnoticed. Every rivet, every cable, every instrument was checked, double-checked, and tested. And yet, despite the complexity, the output never faltered. The German command could only watch helplessly as the balance of air power shifted irreversibly. By mid-1944, the results were undeniable. Ford's bombers were in the skies over Europe, participating in campaigns that would alter the trajectory of the war. Strategic targets, once heavily defended, faced relentless bombing raids that German intelligence had struggled to anticipate or counter effectively. Each plane carried not just bombs, but the embodiment of American industrial ingenuity, a psychological blow as significant as any physical strike. The climax of this industrial achievement was not measured in machines alone, but in human resilience. Workers who had spent months perfecting their craft witnessed the fruits of their labor in action. Engineers saw designs tested under combat conditions. Clerks and logisticians tracked supplies, knowing that every bolt and engine contributed to victories thousands of miles away. The plant was no longer simply a factory. It was a symbol of determination, precision, and the human capacity to overcome impossible challenges. Reflecting on the legacy of the Ford Rouge plant, one sees more than just mass-produced aircraft. It represents an era when ingenuity, courage, and collective effort intersected on a scale never before imagined. It demonstrates how human creativity, when combined with purpose and relentless discipline, can achieve feats once thought impossible. For modern audiences, it is a reminder that innovation often arises from necessity, and that ordinary individuals, working together, can shape history in profound ways. German agents, once stunned and bewildered, had witnessed the rise of a force they could not comprehend, a power that shifted the course of the conflict. And today, that same story resonates, inspiring reflection on how vision, skill, and perseverance can overcome adversity, even in the most daunting circumstances. As we look back, we are left with a question. What can we learn from the factory, the workers, and the engineers who turned raw materials into a decisive weapon? How can the spirit of ingenuity, determination, and collaboration guide us in the challenges we face today? In the end, the story of Ford's 1.5 million part bomber is not just about machines, war, or strategy. It is about human resilience, ingenuity, and the extraordinary things we can accomplish when we dare to imagine the impossible.